Hi, my name is Noel Moya. I am a stem cell scientist, and diabetes has been part of my family my entire life. I was born in the country of Cuba, 90 miles from Florida, into a family of medical doctors. So my father was an internal medicine doctor, and my mother was a psychiatrist. And actually, my grandfather was a dentist. So the medical field was part of my upbringing, was part of my everyday conversations being a child. So it was not a surprise I started medical school in Cuba at the age of 16 and a half. And I did actually 5 years of a 6-year program there. And due to the political instability of Cuba and all the issues with the communism, my family had to migrate into Florida, as many Cubans did during those times. And then from there I have to restart my high-level education. I went to University of Buffalo, and where I got a bachelor's in biology. There I got exposed to genetics, stem cell work, and really was fascinating for me. Really loved it. From there, after that, I moved to San Diego, California, when I worked at several famous research institutes like Scripps in La Jolla, the Salk Institute, and finally University of San Diego, UCSD. Then I did a lot of work with stem cells, and especially at UCSD, I was able to differentiate stem cells towards different type of neurons, cholinergic neurons and glutamatergic neurons. I was able to generate heart cells, cardiomyocytes, and I was able to generate lung cells as well. So all that work yielded several good scientific publications that encouraged me and really motivate me to pursue a PhD. For that, I moved to Germany, and Munich, Germany, in south of Germany, where I was enrolled into the Helmholtz Institute Center there. And there I was in the lab where we were generating pancreatic cells. So essentially, from the stem cells, we were able to differentiate these cells and generate the cells that produce insulin in the pancreas, which the cells that are affected during diabetes. So there I was able to adapt several protocols that I learned in California in order to generate these cells. So I was able to generate the cells in 3D, in suspension. So the yield, the quantity of cells that we were able to generate was greater, was a lot more, and the quality of the cells. So the cells were able to respond much better to glucose fluctuation by secreting insulin. So that was a very good results that we got there. At the same time, I was able, because we were able to generate more cells, I was able to perform several screenings and find different hormones and neurotransmitters that adding these to the protocol yielded much better results. And that's how we modified the existing protocol, and now we have a very, very, very effective protocol to generate these cells. In Germany, I met Danai, and then we talked at length about the possibility to merge our skill sets, my scientific background, her business and marketing head had, and then merge that and create a company so we can bring this technology to the public, so we can actually make a difference, help people with diabetes, make a difference. So we moved back to Atlanta, Georgia, where I was working at the Emory University, and then I did a very good project differentiating cells towards cardiomyocytes in order to generate a biological pacemaker. And around end of 2021, we decided to quit everything and open delphistem. So since then, we have been working hard in order to push forward this technology and to help as many people as we can help. We're very clear, we very understand the amount of people with diabetes in the country and in the world, and we believe we have a technology that can actually change that and can revolutionize the way we treat diabetes. No more insulin injections, no more oral medications, no more glucose monitoring, a transplant of the cells, and then you are good to go. So we are very excited, we're very motivated in order to bring this technology to the public. Thank you so much.